Okay, so we're going to take a look at a reciprocating refrigeration compressor. So a typical way that we may compress refrigerant in our refrigeration system. So this is what's known as a reciprocating compressor. And just to give you an idea of what would be inside of this compressor, um, so we have some pistons that are being pushed up and down in a cylinder. Okay, so the movement in this case of the piston is up and down, and that's what we would consider to be reciprocating, so up and down of that piston and cylinder. This one, this compressor has two different pistons, so we have one that's here on the left-hand side and one that's here on the right-hand side, and typical in refrigeration compressors is that we may have the same refrigeration compressor kind of design, but in order to increase capacity, we may add in additional pistons and cylinders. So you could see typically some compressors that would have, six pistons and cylinders, eight piston and cylinders, two, and generally we always have multiples, often of two, just to keep the machine somewhat balanced. Okay, so let's just take a look at some of the features of this machine. Okay, um, so first of all, here we have sort of the compression end of our system, and we have two places where those pistons are able to push up. So you can see the one here. So it's been cut away, so we can see sort of the internals of the machine. And then over on this side, we have the same, but we have the head covers in place. So this side is what you would see if you saw one in real life, and then this is with some of the parts removed, so we can see inside. Okay, so let's take a look at that piston going up and down. All right, so just gotta position it here. Okay, so my piston goes up and down, and we would have the cylinder that extends all the way up to this plate. And so when the piston retracts, we fill this cavity with refrigerant, and then as it squeezes up, it compresses that refrigerant into a smaller and smaller space. You can see this movement here. There's a couple of components that seem to be moving up and down, and we also have those same components that are on the top side. And these are valves, so these would be called like a reed valve. And what they do is they control the flow of fluid either into the cylinder or out of the cylinder. So this is my intake side, and we have refrigerant that's going to come up through here, and it's going to make its way down through this section. But we only want that to happen on at the right time, okay? And we don't want it to happen when we are trying to do our compression. So these valves are open or able to flap open when the piston is moving downwards, which means that they stay open. And then when the piston starts to come back up, we can see that they build a little bit of pressure, so they flap closed. So here comes the piston back up, and we can see that the valves close and stay shut. Now, there's a whole bunch of different variations of valves, but they all sort of play the same basic role. They allow flow to go only in one direction. On this side here, number 5 is the discharge ports. So we have a couple of holes where the compressed refrigerant can move out. Okay? And our compressed refrigerant comes out through the other side of that head. And so when we have the piston moving up and down, we can see the piston kind of making its way up to the top here. We can see that those valves open and close. And so as the piston is rising up, it allows the valve or the little reed valves to open up, and our high pressure compressed refrigerant is able to make its way out. Ultimately, it collects through a little pipe and it ends up through this part, which is where we discharge. So this is our discharge. And so our high pressure compressed refrigerant makes its way out through this outlet. The inlet for the refrigerant in this case is on the other side of the machine. And so this right here is the inlet. And we draw the refrigerant in, and then it's able to be, it passes through the machine, and it's able to make its way into those inlet side of the head. So this was our inlet valve here, and then we would have the same over on this side. We typically make use of that refrigerant, so we know that when it returns back from the evaporator, it is a vapor and it's still relatively cold. So we can make use of that cold refrigerant passing through our compressor in order to keep it cool. So we know that the compressor is going to create some heat, but we want to make sure that the mechanical components of it are cold. And so we can make use of that cold refrigerant. The other place that that cold refrigerant kind of passes by is this half of the compressor. And this half of the compressor is our motor. So the motor is contained within this cavity here, and that's what turns the shaft, which moves the pistons up and down. One thing that we also have to note is that this compressor, because it has refrigerant in it, and we know that we don't want to have any refrigerant leaks, it has to be completely sealed. And there's a couple of features that I'll point out on this machine that show some of the sealing. Okay, so first of all, in order to keep this machine running, it has to be lubricated. So we need some oil inside. Now, the oil, we can check the level here at number 6 to see how much oil is in this machine. We don't use a dipstick, which we may typically use on a regular air compressor, because if we have a little dipstick to check the oil, that's a opportunity for refrigerant to leak out, especially when we're testing for that oil level. So one thing that we have would be typically a sight glass to see what the oil level is. We also have some ports that we may use for either draining oil or adding oil. So we probably have some sort of external tube here that we can use for adjusting the oil level or changing the oil. Again, that's a process that's going to be somewhat complicated, more so than an air compressor where we can just drain it and it can be exposed to the atmospheric conditions. One other thing just to point out here that we have, so this section here was our discharge. So that was where we had our hot, high pressure refrigerant that was leaving this compressor. We also may need to isolate this, so there may be cases where we want to close off the flow. And so what we have here is a valve that we can open and close the pathway for refrigerant leaving this compressor. Now, it looks a little different than valves you may have seen before. And again, with the principle that we can't have any leaks of refrigerant and we don't want air to get in. So we have to keep this as a sealed system. This that we see here is where we would typically have the hand wheel on a valve. So we would turn this valve to either screw it in or unscrew it by having a hand wheel here. Well, that shaft which turns is a potential spot for leakage. So typically what we have on a refrigeration compressor is when we're not using a valve and we don't need to open and close it, we would typically remove the hand wheel and we replace it with a cap. So this is kind of a closed off sealed cap that goes over top of the end of the valve. And if we need it to open or close it, we could carefully remove this valve to make sure there wasn't any major leaks that were happening, replace it with a hand wheel, and then make our adjustments to that valve and then replace the cap afterwards. So I think that's a good overview of our reciprocating compressor. We're going to take a look at one of these in real life in one of our labs this year, but this at least gives you an idea of what some of the features will be, and we'll talk about the valve operation a little bit more in class.